we're looking at lesson 1.6, functions and operations and composition of functions. A lot of this should be review from Algebra 2 with a couple minor changes in how we write our domain and range. So we have learning targets that we're going to focus on in day 1 are performing operations with functions and finding composite functions. And with both of those learning targets, we need to be able to state the domain of the resulting function. So for operations with functions, we have the following function. What operations do we have with numbers? There's four primary operators. What are they? Yep, addition, subtraction, multiplication, which we normally just put a dot. I'm going to put an asterisk, but normally it's a dot, not an x, because that's a variable, and division. There's 2 of these that we need to be particularly careful with, whether I'm working with numbers or variables, but especially when I'm working with functions that have variable expressions. Which 2 do I need to be particularly careful with? Multiplication, I want to make sure I distribute everything right, but in particular, I need to be careful with subtraction and division. Remembering that when you are subtracting 2 quantities, you actually need to subtract all of the second quantity, not just the first term of it if it's an expression. For example, our expression might be 3x squared plus 2x minus 10. I don't want to just subtract the 3x squared by just writing a minus in front of it. I need to put that entire function that I'm subtracting away in parentheses and then do what? What do I do with this? Distribute the negative, and that way I make sure that they all have the correct sign. So that's one thing we want to look out for and be very careful about. The other thing comes with division, and it may be something as simple as I have x by x plus 2 up here, and down here I have, x by x plus 1, and down here I have x squared plus 2x plus 1. Can I leave my answer like this? What do I need to do? Factor, one of the F's of mathematics. So we're going to factor it to see if we can reduce it, right? Whenever we do these operations, add, subtract, multiply, or divide, we're then supposed to simplify, whether it's numbers or variable expressions. So this is actually x plus 1 over x plus 1, and one of those factors will divide away. Okay? So we have to be careful when it's division to make sure we try to reduce it. So even if it doesn't reduce, I should see that you have factored it to try to reduce it. Another caution, and just because I have people who do this all the time, we got 3 minus 5 over 3 times 2. You don't have to write this down. But I have people all the time who do this. They cancel out the 3's. And then they're like, oh, yeah, that's negative 5 halves. Now, they don't do this with numbers because they know it doesn't make sense with numbers. But with variables, they do it all the time. Is this really negative 5 halves? No. It's actually negative 2 over 6, which is negative 1/3. Now, notice there was a minus sign. The only time you should be canceling out factors is when you have the products of factors in the numerator and the products of factors in the denominator. For example, if I had instead had, let's see, we've got 3 minus 5. So let's say instead I had 1 times negative 2, and then I had 3 over 2. Well, now that they're all in parentheses, everything's being multiplied, now I can cancel this factor of 2, and it gives me the equivalent fraction of negative 1/3. So if it's all multiplication and division, you can simplify. If there's a plus or minus sign, you have to treat it as its own factor and try to simplify it first. All right, so composition. We have the following functions. We have f of x is x squared plus 4x. G of x is the square root of x plus 2. And h of x is 3x minus 5. Find each function and its domain. Are there any restrictions on any of these functions right here as they are originally? Yeah. How many functions have domain restrictions of f, g, and h? G, I can only think of one, too. You're right. There is only one. It is G, right? Why? Because there's a square root. Can I take the square root of positive 9? Still get a real number? Absolutely. Square root of 1? Absolutely. Square root of 0? Absolutely. Square root of negative 1? Yeah, but it's not a real number. So when we talk about our domain, we only want it for real numbers. So our restriction, and you will want to remember this, most people got it okay on the quiz, but some people struggled. Whatever's under your radical, if there's an x involved, an expression involving x, your radicand, that entire radicand, everything that's under there, has to be greater than or equal to 0. So we're talking about domain restrictions, or just reviewing domain restrictions. What else? What if I have 1 over something that has x in it? What do I have to do with that denominator? Well, if it's just an expression, like x plus 1 or something, it has to not equal 0, if it's just an expression. But if it is a radical, you're right. If it's a square root, if there is a radicand in the denominator, a radical in the denominator, and it's an even radicand, then that radicand has to be strictly greater than 0, just like you said. So if it's in the numerator, it can be 0, so it's greater than or equals 0. But if it's in the denominator can never be 0, so in this case, it has to be strictly greater than 0. Those are our 3 primary restrictions that we're looking at as we look at functions and their domains. So when I see letter A and it tells me to add functions g and f, I have function f, which is x squared plus 4x, and function g that I'm just adding to it. And I don't have any like terms, because really this is an exponent of 1/2. It's x plus 2 to the 1/2 power, but we leave it written as the square root of x plus 2. And I can't combine anything. Okay, to combine radicals, they have to have the same radicand. We don't have any other radicals. So this is the function, the sum of functions f and g, but we're supposed to state its domain restrictions. When I look at the function before it's simplified, so when you're doing this, you're going to look at the function that you've made, look at the made function, the new one, before you simplify. Well, we didn't even have to simplify. Before you simplify, to identify domain restrictions. Well, even before I simplify, I have the same function. The domain restriction is, hey, look, there's that radical there, and the radicand, x plus 2, has to be greater than or equal to 0, which means if I subtract 2 from both sides, x has to be greater than or equal to negative 2. In Algebra 2, that's how you left your answer. But in PreCalc and in calculus, we write it in interval notation. So our domain is, the minimum is negative 2, and it can be included in the domain. And that's just the minimum. There is no max, so it goes to infinity. So there's my resultant function when I take the sum of those two, and here's its domain. It's not all real numbers for that one. For letter B, what do I have to be careful of? It's supposed to do f minus h, right? So f is x squared plus 4x minus h is 3x minus 5. Did I do it right? No. Whenever I'm going to subtract, I better put that second function in parentheses to make sure that I take away every single term, not just the first term. So I'm going to distribute the negative. I'm going to get negative 3x and positive 15. And now we can combine like terms. So this is going to give us x squared plus x plus 15. 5, thank you. I don't know why I got 15. Plus 5. I distributed the 3 apparently too. Yeah, just 5. Thank you. Just the negative got distributed. All right, so this is our resultant function from the subtraction of those two functions. And I look at it before I simplify. Before I simplified, this didn't have any restrictions. It was a linear function. This didn't have any restrictions. It was a, it was a quadratic function, thank you. And together it's a quadratic. There's no domain restrictions on any of those. So my domain, normally in Algebra 2, you just say, oh, it's all real numbers. There's no restrictions. So here you say negative infinity to positive infinity. That's the notation for all real numbers. All right, go ahead and try, let's take a look at go ahead and try letter C and D. Take a moment to pause the video and try letter C and D. See what you remember from that, and we'll go over those in a second. If you did these correctly, you should have for letter C 3x cubed plus 7x squared minus 20x. And for letter D, 3x minus 5 over x squared plus 4x, which if you factored, you could have left it as x by x plus 4 in the denominator. Still not able to cancel any factors, so that's the resultant function. You can give either one of those as an answer. I should see that you factored to try to reduce it, though. So on the first one, f times h, you had x squared plus 4x multiplied by 3x minus 5. You can choose to FOIL if you want, which is doing the first terms together, then the first terms, then outside, inside, last. I don't do it that way. I just distribute my x squared to both terms. It doesn't matter. You can do it either way. This is 3x squared minus 3x cubed minus 5x squared. Then I distribute my 4x, gives me 12x squared minus 20x. And then you combine like terms. So 3x squared, these two combine to 3x cubed, 7x squared minus 20x. Domain restrictions. I look at it before I simplified, before I actually did anything. There were no restrictions on this domain. There were no restrictions on this domain. And then when I put them together, I just have a cubic function. A polynomial function doesn't have domain restrictions. So it is all real numbers, which in interval notation is negative infinity to positive infinity. Letter D, the original function had no domain restrictions, 3x minus 5. I put that over the other function, x squared plus 4x, and that one by itself had no domain restrictions. We had a linear function, we had a quadratic, no domain restrictions. However, I didn't simplify here, but even before I simplified, we have a problem. What do we have that we have to be careful of? What do I need to be careful of in that problem? When I'm thinking about possible domain restrictions. Denominator. I have variables in my denominator, and those cannot equal 0. Even though as its own function it had no restrictions, now that it's in the denominator, it creates restrictions. So we have x by x minus 4 cannot equal 0. This means that x cannot equal 0 and x cannot equal 0 and x cannot equal 4, which gives us a domain of anything before 0, anything between the two, and another interval from anything greater than 4. So my final answer for that, for my domain, is negative infinity to 0, joined with 0 to 4, joined with 4 to infinity. There are actually 3 intervals that I have to write down instead of just x doesn't equal 0 and x doesn't equal 4. Now, I want to make this point very clear. If I had a function, and if you want to write this down on the side of your paper, you can, but you don't have to, that after I put them together, let's say I had x squared plus x over x squared plus 2x plus 1. Well, you factor that, you get x by x plus 1. Now you have x plus 1 by x plus 1. What's going to happen here? It's going to cancel. Before I simplify, I need to look at my domain. Because what happens when it cancels out? What's that create on the graph? A hole. Is there an x value for that hole? I mean, there's an x value for where it's at, but it's not part of the domain, right? So I don't want to cancel it out and just write x over x plus 1 and say, oh, my domain restrictions is x can't equal -1. Well, that in this case it would cover it, but let me change this, sorry, to an x plus 2. Okay? Well, in that case, there would also be that x cannot equal -2 because that's where the hole is going to be. So you want to look to try, before you start reducing to do your final simplification, when you plug it in, you want to look right then, what are my domain restrictions? These two factors cannot equal 0. Okay? Don't reduce and then give me just one of them. Okay? All right, composite functions is where we plug one function into the other. You've done this in Algebra 2. So we have f of g of x Which one's plugged into the other one? Which one's inside the other one's parentheses? X is inside of g, and g of x is inside of f of x. Okay? So the other way to write this, and you should have seen it in Algebra 2, is FOG. It kind of looks like fog. This is not really an O, and it's not a time symbol. Okay? Don't be confused. If it's an open circle, that means composite function. That's very different from f times g, which with it closed means multiply. So pay attention to the symbol. If it's closed in, it's multiply the two functions. If it's open circle, it means plug this function into f's function. So you might see fog, or you might see goff, or even hog. So goff is g-o-f. That's read g of f, which means that I'm taking function g, and I'm plugging in the second one, plug in function f. So this symbol means plug in the second. Plug the second function into the first. So for letter A, we have these functions. We have a quadratic and a linear function, and neither one of those has any domain restrictions yet. We'll talk about domain restrictions in a minute, though. And this is f of g of 2, not x. Okay, that's okay. So this means that I have g inside of f, and inside of g I have 2. So what do I plug the 2 into first? G. That's what this means. You're kind of working backwards in this statement. Plug the 2 into G and then plug that into F. It's starting with the 2 and working right to left. It's a little backwards in terms of how we think about reading things. So I plug the 2 into G. Here's G. This is x minus 4. And I'm putting a 2 in. 2 minus 4 is -2. I take my answer from G and I plug that into F. F is x squared plus 1. So when I plug in that -2, I get 4 plus 1, which is 5. Try that for letter B. If you did B correctly, you should have gotten an answer of -2. So what we're doing is plugging F into G and -1 into F. So inside F I have F is x squared plus 1, and I plug in the -1. That gives me 1 plus 1, which is 2. I take that 2 and I plug it into G of x, which is x minus 4. And 2 minus 4 is -2. Any questions on that? All right, that's a little different when we're actually plugging in numbers than when we're plugging in the function. It's a little easier when we're plugging in the function. Here's the question. Which one am I plugging into the other one? Am I plugging in G into F or F into G for letter C? F into G. I'm glad you can see that. So G is x minus 4. That's G. By the way, this is G of f of x. And so now I'm going to plug f into it. This is x squared plus 1. Before I simplify, I look at my function, and we'll talk about that in a second. So I've got x squared minus 3. There's my resultant function. Try this for letter D. Do fog f of g of x. Yes, sir. X squared minus 8x plus 17 is correct. So for that particular problem, you would plug g into f. So f right now is x squared plus 1. G is x minus 4. You can't distribute the squared because these aren't multiplied, they're subtracted. So I have to actually expand it as x minus 4 by x minus 4, which is x squared minus 4x is minus 8x. Negative 4 times negative 4 is positive 16. Bring down, don't forget to bring down terms. Some of you forgot that on your quiz. The plus 1, and it leads you to x squared minus 8x plus 17. Any questions on letter D? All right, flip on over to the other side. We're going to be finding the domain of f of g of x, which we know is plugging g into f of x, but I could also ask for g of f of x, so just pay attention to which one it asks for. Also pay attention that that's not a multiplication sign, it's an open circle, which means we're doing composition of two functions, or composing a function from two functions. Before I do this, I look to see if there's any domain restrictions. You can either look before and at the end and then put things together. My suggestion would be to, once again, look at what you have before you simplify. Look at function or composed function. Before you simplify to identify any restrictions on the domain. Look at the composed function before you simplify it, before you start canceling out factors or combining stuff. See if there are any things that stand out to you as having a domain restriction. So we have f of g of x, and we'll look at the end too, and then look at the end again. Because sometimes after we put them together, we get a domain, we get something. So here we have x squared minus 2. When I plug this in, I've got the square root of x minus 3. I'm going to ignore what I just said for a second and show you what would happen if you ignored it. So what's going to happen to the square root? It's going to go bye-bye. I have x minus 3 minus 2. I get a function of f of g of x equals x minus 5. And I'm like, oh, that's a linear equation. The domain of that is all real numbers. Right? So if I just went to x minus 5 and hit graph, you're like, oh, there's my line. I did it right. I got all real numbers. Well, the problem is I don't want to simplify before I consider what the restrictions are. These two composite functions are put together here, but I notice that before it's simplified, there's a problem. Because according to order of operations, the square root happens before I square it based on how this is written here. So there's domain restrictions on x before they get plugged into the quadratic. So those restrictions can be found as x minus 3, what do I write? X minus 3 can equal 0? Is greater than, or is greater than or equal to? Greater than or equal to, correct. So this means x is greater than or equal to 3, which as a domain would be anything including 3 and higher. So to infinity. Now let's take a look at what happens if I plug this in. By the way, it doesn't always work, so be careful. I've got square root of x minus 3. Don't need to close them anymore. Close this parenthesis and square it, minus 2. And now when I hit graph, instead of seeing that full line, you can see right there that it starts where x equals 3 is our first x value on that graph, the first part of our domain. So whenever you plug a function into another one, before you do any simplifying, look to see if there are any domain restrictions. And then look again at the end. At the end, there's nothing, so everything that happened here is my domain restriction. So for letter B, we're supposed to do f of g of x. I have 1 over x plus 1. I'm plugging, remember, it's f of g of x, so g gets plugged into f. G is x squared minus 10. Even before I simplify, I know there's going to be domain restrictions that come from this denominator. That denominator simplified, not getting rid of any exponents or anything else like that, is x squared minus 9. Now this one you would have lucked out because nothing cancels. You wouldn't miss any restrictions. You would notice right away that, hey, here's my answer, but x squared minus 9 cannot equal 0. Now here's where I had some people go wrong on their quiz. Many of you would write this as x minus 3 by x plus 3 cannot equal 0. So you got your two restrictions, x can't equal positive 3 or negative 3. Some of you solved this by adding 9. And so you said x squared equals 9, you did the square root, and you just wrote 3. What did you forget? Plus or minus. Whenever you take that square root, it's plus or minus the square root when we're doing it through solving. So there's actually 2. And there will, because there are 2 interruptions in the domain, and otherwise it would be all other numbers, we have from negative infinity up to negative 3, and then the numbers between negative 3 and 3 to infinity. So our domain is negative infinity up to negative 3, joined with negative 3 to 3, joined with 3 to infinity. So 3 intervals to say, hey, it can't be 3 or negative 3, but anything else it can be. Try this for letter C. Let's see if you can do that problem. All right, for letter C, you had 5 over x for f, and we're plugging g into it because we're supposed to be doing f of g of x. So this is x squared plus x. It doesn't reduce. I could try to factor, but there's no x's in the numerator, so I'm not even going to bother because I know it's not going to reduce. This is my final function. We didn't do any simplifying, but even if we were going to, even before we do, this denominator cannot equal 0. So x by x plus 1 cannot equal 0, which means x cannot equal 0, and x cannot equal negative 1, from those two factors being set equal to 0. So in interval notation, our domain is, who can tell me the domain? It's going to be 3 intervals. Anybody have 3? Sorry, what is it? Yeah, negative infinity, negative 1. Negative 1 to 0, or 0 to infinity. All of those include our domain. Great. Any questions on C? All right, for letter D, when I put f into, or g into f, I have 3 over x. That x is the square root of x minus 2. Now, there's not really going to be any simplifying, but I'd still look at this as 2 problems in the denominator and under the radical. So simplified, this will be the function of f of g of x. But when I go to write my domain restrictions, x minus 2 has to be strictly greater than 0. So x has to be greater than 2. So that would be, in parentheses, 2 to infinity. We're going to look at how to decompose functions later. There's actually several ways to do each type of problem. For today, your assignment is the following for day 1. You're looking at section 1.6. It's on your assignment guide also 1 to 11 odd, 15 to 19 odd, 21 to 26, and 30 to 39. Tomorrow we'll have a worksheet that does some of these types of problems again, but it will also have the decomposing functions. That's it for day 1 of 1.6.